globes on May 1, 2024. A seemingly ordinary sunspot appeared on the eastern edge of the Sun. At first it was nothing, unusual, just one of the many sunspots that come and go. But as the days passed, this sunspot grew at an astonishing rate, swelling to a size 17 times larger than Earth itself. Scientists labeled it Active Region 3664, and it didn't take long to live up to its name. This colossal sunspot unleashed fierce solar flares, some so intense they initiated coronal mass ejections directly at Earth. The outcome, one of the most stunning aurora shows in recorded history, with brilliant lights stretching across the world to regions that had never witnessed them before. As per NASA, this was the strongest geomagnetic storm in 500 years, and it even shook observatories deep underground. The Sun didn't calm down following the peak solar storms in May. Instead, it kept on releasing bursts of M and mild X-class flares. With space weather scientists on high alert then, on October 3rd, it emitted a massive X9.0 flare, the strongest seen in 7 years, straight from the center of its disk a week. Later, a mighty full G4 geomagnetic storm lashed Earth, illuminating the skies with spectacular auroras in locales. Unaccustomed to such spectacles and interfering with radio communications in some sections of the world, all of which indicated one thing: the approach of solar maximum. Now NASA has officially confirmed it. The Sun's magnetic field has flipped, and the solar maximum has arrived. So what will the solar maximum do to our planet in the coming month? How long will this period of heightened solar activity last? Finally, and most importantly, will this increase the average global temperature and warm our planet over the next year? The Sun may look like a bright, constant ball of light, but it's far from steady. Every 11 years or so it goes through a dramatic transformation known as the solar cycle. This cycle, which affects our planet in many ways, includes changes in the Sun's activity, magnetism, and even appearance. The discovery of the solar cycle was made in the late 1700s when astronomers observed something odd while monitoring sunspots, dark regions on the surface of the Sun. Astronomers noticed they didn't occur haphazardly. Instead, the quantity of sunspots increased and diminished in an irregular pattern over time. The observations were that sunspots rose and fell in number annually, every 11 years a cycle, which scientists would later refer to as the solar cycle. After discovering this, astronomers began closely monitoring this event for a very long time. They documented solar activity by measuring the activity of sunspots alone. But with advances in technology, they noticed two additional things that varied in a solar cycle. The first was the solar magnetic field. Our Sun is a giant ball of charged gas or plasma, and its magnetic field is continuously oscillating. Astronomers discovered that the magnetic field experiences a complete reversal of poles with every solar cycle. This implies that the solar magnetic north turns south and the south turns north. The pole reversal occurs around a solar maximum at a cycle's midpoint. The other feature of the Sun, which varies with the solar cycle, is its total activity, including solar wind flares and coronal mass ejections. This activity peaks at its greatest amount at the solar maximum and least at the solar minimum. Due to these discoveries, observing solar cycles now entails observing solar activity and polarity reversal in addition to counting sunspots. Since the earliest detection of solar cycles, astronomers have monitored each cycle and numbered them. Numbers were presently in solar cycle 25, yet each of the previous 24 cycles had distinct characteristics, while the majority followed the predictable course of increasing to a peak, with numerous sunspots and then falling into a quiet minimum. There were two bizarre epochs in history that we still cannot explain, just as we watch each solar cycle with reverence, wondering what secrets are in its rise and decline. Moag Globes allows you to bring that same awe of wonder right onto your desk, powered by ambient light and concealed magnets. They rotate silently, generating a peaceful and enchanting show in your home or office. No batteries, no cords. Just a charming showcase of science. On your desk, MOAG Globes offers more than 40 engaging designs, including an outer space series that includes planets, moons, asteroids, and constellations. It's a great way to keep the wonder of space within reach every day. And for fans of this channel, I've made a special deal. Use code SOMOB.com to receive 10% off on 6-in and 8.5-in MOAG Globes. So check out the link in the description and take a piece of the cosmos home. Now back to the Sun. The first unexplained span is the Maunder minimum, a period of very low solar activity between 1645 and 1715. During those 70 years, sunspots became almost non-existent, with astronomers seeing only some 50 sunspots during the whole period, whereas thousands normally show up in one cycle. This prolonged solar minimum coincided with a time known as the Little Ice Age, when parts of the world experienced colder than average temperatures. Rivers that rarely froze, like the Thames in London, iced over, and Europe faced harsh winters following the Maunder minimum. The Dalton minimum occurred from about 1790 to 1830. Although less extreme, this period also had lower than average solar activity like the Maunder minimum. The Dalton minimum coincided with a phase of cooler global temperatures. Major volcanic eruptions at this time, such as the 1815 eruption of Mount Tambora, also helped cause global cooling, forming what has come to be known as the year without a summer in 1816, when there were widespread crop failures and food shortages across Europe and North America. Solar cycle 24, which began in 2008, was exceptionally weak. Sunspot numbers in solar activity were far below average, making it one of the least active cycles in more than a century. Scientists were taken aback by its low intensity, as it had far fewer solar flares and coronal mass ejections than expected. This quiet cycle raised questions about what causes such variability in solar activity, and whether a future grand minimum similar to the Maunder minimum could occur when the current solar cycle began. In December 2019, it was predicted to be even weaker than the preceding cycle. But we were wrong. Solar cycle 25 beat all expectations. In August 2024, the average daily sunspot number likely reached 229, more than twice the expected value. This level has not been seen in over 20 years. An interesting twist in the current solar cycle is that its peak came earlier than scientists expected when this cycle began. In December 2019, prediction targeted a peak in July 2025, with about 115 sunspots, but by January 2024, NOAA's space weather forecast adjusted its prediction, now looking for the peak to occur between January and October 2024, with a more intense reading of 137 to 173 sunspots on October 15th. NASA verified that the solar maximum phase has officially begun. However, NASA's release doesn't indicate that this is the peak level of solar activity we'll experience while the Sun has reached the solar maximum phase. Pinpointing the precise peak of activity will take months. Scientists have to monitor solar activity for months, possibly years, to verify the actual peak, only established after observing a continued decline. Most noticeably, the last 2 years have already exhibited high activity, with frequent sunspots indicating this active phase. Scientists now anticipate that the Sun will remain at its peak phase for roughly another year before it starts its slow fade back to a milder phase called the solar minimum. This indicates the next several months are going to be crucial, and we can anticipate extreme geomagnetic storms and breathtaking auroral displays. Numerous potent solar storms in recorded history have left a lasting effect on Earth. The Carrington Event is the most well-known and powerful solar storm in recorded history. It happened on September 1st and 2nd, 1859, when British astronomer Richard Carrington witnessed a huge solar flare only hours later. A coronal mass ejection crashed into Earth, releasing a powerful geomagnetic storm. Telegraph systems in Europe and North America went haywire. Some telegraph operators complained of receiving electric shocks, while others noticed that their machines operated even with the batteries removed, powered by nothing. The storm caused electric currents. Aurora Borealis sightings reached as far south as the Caribbean, lighting up the night sky brightly enough for humans to read newspapers. Outside, according to No. Gold miners in the Rocky Mountains awoke and prepared coffee, bacon, and eggs, believing the sun had already risen on a cloudy morning. Two men operating the American telegraph line between Boston and Portland were able to communicate for 2 hours using no battery power and operating only with the current caused by the aurora while they were exchanging. They even commented that the communication was more understandable than when batteries were being used then. In May 1921, the notorious New York Railroad storm hit our world. It was the most severe geomagnetic storm of the last century. Even though there were no satellite systems, then it still caused havoc to Earth's electrical infrastructure. Particularly, the storm resulted in a fire in a railway station in Brewster, New York, and interrupted railroad signaling systems throughout the northeastern United States during August 1972. A severe solar storm hit Earth between the Apollo 16 and Apollo 17 missions, too. The Moon. This solar flare was so strong that if astronauts had been in space at the time, they would have had lethal doses of radiation. It also ignited mysterious ordnance explosions off the coast of Vietnam, as the intense magnetic field initiated sensors. In the mines then, in March 1989, a severe solar storm brought Earth's modern electrical grid infrastructure to its knees in Quebec, Canada. The storm caused a major blackout, leaving about 6 million people without power for over 9 hours. The electrical grid collapse was so severe that it caused voltage instabilities and transformer damage across North America. The event highlighted the vulnerability of power grids to solar activity and prompted new protective measures in energy systems worldwide. More recently, in early 2022, a flare from the sun was powerful enough to cause geomagnetic storms, resulting in the loss of 40 newly launched Starlink satellites. Today, our society heavily relies on satellites and various technologies that need stable magnetic environments to function correctly. This dependence makes us more vulnerable to the effects of significant solar activity. Any disruption could lead to trillions of dollars in monetary losses and pose risks to life dependent in these systems. The potential impact of a Carrington-class event today has been estimated to result in damages ranging from 0.6 to 2.6 trillion in the U.S. alone. Now we reach an important question: does solar activity play a role in the rise in Earth's temperature, thereby inducing global warming during solar maximum? There's a slight increase in the total solar irradiance quantity of solar energy striking Earth, which can trigger minor fluctuations in Earth's climate. However, these differences are comparatively modest and have limited effects on global temperatures. This graph depicts a correlation between solar activity and Earth's temperature. To the close of the 20th century, the quantity of solar energy Earth receives has conformed to the Sun's natural 11-year cycle of tiny ups and downs, with no net rise since the 1950s. On an equivalent period, global temperature has increased substantially, contradicting the view that the Sun has been the major cause of the observed global warming trend over the last half-century. High solar activity may potentially affect NASA's Artemis missions to the Moon. Mission procedures are well established to avoid launching during solar storms. This is because of the risk posed by the high-energy particles from these storms to sensitive electronics and the threat of interference with radio communications, which could make keeping contact with the spacecraft difficult, if not impossible. But there's a welcome bonus to all this solar flare activity. During intense solar periods, the Sun's magnetic field actually shields Earth and its satellites from cosmic rays, originating beyond our solar system. This means that high solar activity offers extra protection against cosmic rays, making satellites less vulnerable to the long-term damage. These particles can cause one of the most exciting things about the solar maximum period is the possibility of witnessing auroras when a coronal mass ejection collides with Earth's magnetic field. It sets off a mesmerizing chain of events. As the storm approaches, Earth's magnetic field acts like a shield, deflecting much of the charged particles, but the magnetic fields of Earth and the solar storm are able to connect up, forming a funnel, where charged streams of gas flow down toward the day side of Earth's poles, to form a rare daylight aurora. As the storm rages on, the magnetic field stretches back further like an elastic until it breaks, projecting gas streaming down magnetic field lines to the night side poles. This creates the stunning nighttime aurora displays. While we typically envision auroras as green, particularly energetic displays can light up the sky with dramatic red hues. These color changes are based on the kind of particles and the altitude at which they collide. Green auroras happen when solar particles collide with oxygen at altitudes between 100 and 300 kilometers. In the meantime, the uncommon red aurora, such as the ones we have seen in May, are created when the particles collide with oxygen even higher up, between 300 and 400 kilometers. For these red auroras to be visible to the naked eye, they must be at least 10 times brighter than their green counterparts, making them a truly spectacular sight. The best places to see the auroras include Canada, Alaska, Iceland, Norway, Sweden, Finland, Greenland, Tasmania, and southern parts of New Zealand, where they light up the night sky with breathtaking beauty. As we gear up for the solar maximum, it's a powerful reminder of where we stand in a vast dynamic universe, challenging us to look beyond the routines of day-to-day life. So thanks to you for watching.